Okay, the official video has begun recording. Whatever you say now is going on the internet. So no fart noises and no changing backgrounds. Okay, Lucas and Meridel have attended today. Everybody else decided that it's not important for them to just click on the button at the right time. But this is being recorded, and they're going to have to watch it, and they're not going to get any help with their homework. I'm going to put my hand down now. Okay. Man, I'd love to, not be right there. It's scary. There's, a camera and a camera. Let's see. Apparently, I'm the only one here. So, Lucas, if somebody comes by today, make sure that they either text me or come up to my room, okay? Your stuff's actually at the office, but nobody's there and the door's locked. Okay? All right. Okay, folks, just remember, each day it's do a lesson. And when we come back, you better bring us a bunch of stuff, and I'm going to have to sit and grade it all. Okay. Let's start with some power-up stuff. I'm going to write it down, and I might not pick the exact same thing that's on the power-up, but these are like what you'll see on the power-up test on Friday. In fact, I'm going to change this one. Okay, let's start with these two. Meridel, you put your fingers up for the first one, and Lucas, you give me some signal for the bottom one. Oh wow, where'd your fingers go, Mer? Oh, 7 fingers. That is correct. 10 to the 3rd and 10 to the 4th is 10 to the 7th. Okay, Lucas, the bottom one's yours. 10 to the 5th divided by 10 to the 3rd.
Uh, 10 to the 7th, 8th?
Nope, you're going the wrong direction. Subtract rather than add.
To the second power.
Yep, okay. And the reason for that is that 10 to the 5th, 1, 2, 3, 4, is 5 tens, and 10 to the 3rd is 3 tens. So if we start canceling stuff out, that's 1, 2, 3 tens are canceled out. There's only 2 tens left. 10 times 10. Eraser. Okie dokie. Let's keep going because I want you guys to get 100% when you do it on the test. Okay, Meridel, you get the top. And Lucas, you're going to get the bottom. 10 cubed squared. 10 cubed squared. And 10 to the what power is 1 for Lucas? Okay, Meridel, you got an answer? 10 cubed squared. She says 6 and Lucas says 0. And you are both correct. Well done. We're using the power rule here. Cubed squared, that's cubed times another cubed. 3 plus 3 is 6. And then anything to the 0 power is 1. So this doesn't have to be 10. This could be 17 to the 0 equals 1. And it would still be true. All right. Okay, I've changed them again a little bit from what we've been doing. Meridel, you get the top. Lucas, you get the bottom. X to the 4th times to the 7th. That is correct. Sorry, Lucas, take that away from you. There you go. Lucas gets x to the 8th divided by an x. How many x's are left?
8.
Nope. We're dividing out one of them. Sorry, I didn't even put the little, we could think of it as like it's x to the 1. So same rule as last time, we're going to subtract.
Oh, 7.
Yep. Got it. Okay, so again, just because it's letters instead of numbers, this still means multiply. You got 8 of them, and you got divided by one of them. One of them's going to cancel out. You'll be left with 7 on the top. And Meridol went 4 and 5 is 9, and then minus 2 is 7. So you add up here, and you subtract what's down there. Okay, I'll do a couple more. I'll give Lucas a power one here. Okay, Mare, you get the top. Lucas, you get the bottom. Merida left the meeting. All right, Lucas, it's you. She'll come back. Okay, so on the bottom, it's x to the 4th 3 times. Oh, there she is. When did she come back?
Right.
Who? Who talked? Who said that?
Me.
Oh.
Okay.
Nope, 4 times 3.
7.
4
Oh.
times... Yeah, good. 4 times 3 is 12. Caught yourself.
I accidentally hit the leave call button.
Oh, I see.
Instead of the-
Okay, Meridel, what's going on the top?
7 minus 3,
Yes.
4.
Good.
X to the 4th.
Okay. All right. Now, one thing to see here is that the bottom stuff would add up together to 2 plus 1 is 3. You'd have an x to the 3rd on the top and x to the 3rd on the bottom. They cancel out, and this is the only part that would be left over. And then Lucas's down here would be 3 of these, which would be x to the 4th, x to the 4th, and x to the 4th. You could go 4 plus 4 plus 4 if you want to. But it's quicker just to go, if they're sitting right next to each other, we multiply. Multiply those numbers. Okay, I'm going to stop there. There's really 3 rules plus the 0 rule, but that's kind of a given. That's going to be very similar to what we see on when you open up your envelope for your test. And they've been putting ones like that in the lesson. All right, open up the page to page whatever, lesson 35, and we'll do the mental math. Maybe we'll do that one at a time as well for the viewing pleasure of our internet audience. If you're tuning in to watching this on the video, then you need to make sure that you are doing these as well on your own. What lesson are we on? 35? There. Ooh, we got some weird names in here today. I mean, culturally diverse. That's what I meant. All right, we'll do them together, one at a time. Number sense. $22 divided into 4, and x minus 12 equals 48. Here we are. Here's our first 2 mental math problems. And again, whenever I see divided by 4, I divide it by 2, and then I divide it by 2 again. I don't think about divided by 4. I think about divided by 2, divided by 2 again. So that makes the first bit easy. What would be 22 divided by 2?
11.
11. Okay, so this is the same thing as 11 divided by 2. That would be step 2. Okay, well, that's a little trickier, but I think 11 is close to 10. So half of 10 and then half of 1. And put those together, and what do you got? Money-wise.
$5.50.
There you go. $5.50 each. Okay, on B, we can do this by inspection. We're supposed to do mental math here. Something, and then we're going to take 12 away, and we're left with 48. So the number's got to be bigger than 48. All right, it's 12 bigger than 48. Later on, we'll add 12 to both sides to solve for x. But just think, what's 12 bigger than 48? 60. And we check. 60 minus 12. Yes, that's true. Check. Smiley face. Laser bolt. Okay. C. Find the temperature indicated on the thermometer. Oh, hot dog. Okay, 20, 30, and 1, 2, 3, 4. 1, 2, 3, 4. And we're right. 1, 2, right there. Okay, and rate.
Actually, I'm gonna be right back.
Yeah, you are. She's going to the bathroom, everybody. 100 yards in 1 minute. Feet per minute. Okay. Got a thermometer, really lame thermometer. And in order to figure out what the temperature is, we have to look at how many marks there are between 20 and 30. Okay, there it looks like there's 1, 2, 3, 4, 5 spaces there between 20 and 30. Okay, between 20 and 30 is 10, so each line has got to represent 2. So we're past 20, we're 2 marks past 20. What would be the temperature here, I guess, in degrees Fahrenheit? Either of you.
24.
24 degrees, right. So the only thing we're doing there is figuring out what that scale means, what the marks indicate on the temperature scale. Okay, the bottom one. What's her name? Mei Ling can go 100 yards in a minute. Yes, indeed. Mei Ling, we honor you. Well done. What would that be in feet per minute? So really, the only thing we need to do is to change that 100 yards into feet. How many feet are in 1 yard?
3.
3. And so we're going to multiply that by 100. How many feet can she go in 1 minute?
300.
300 feet in 1 minute. Good job, Mei Ling. To the web market. Scientific notation. Write 5 billion in scientific notation. It's a lot of zeros. 5 billion. There it is. We want to write that in scientific notation. So we're going to move that decimal point from here all the way to right there so that we have, this is going to be hard, 5. So we have 5 times 10 to the something or other. Okay, how many decimal places do we have to move it?
9.
9 stinking zeros there. Okay. All right. 5 times 10 to the 9. Scientific notation. Alrighty. Geometry. 2 sides of a triangle are 7 and 9. I'm going to draw a couple of pictures here. Okay. The question is, what's the biggest the third side could be? Sorry, that's a 7. If I want to connect the edges here. Oh, I missed. What's the biggest that this side here could be? Has to be a little bit less than what number? What if this was a straight line of 7 plus 9? Then what will we have?
18.
Yeah, wait, no.
16.
16, right. Okay, so if it was like this, we wouldn't have a triangle. But if it's a little bit more than that, we can make a really long triangle. And the biggest, this one has to be a little bit less than 16. That's the biggest that could possibly be. Because two sides of a triangle cannot add up to the third side. It has to be less than that. Same thing if we close this and we make it a really small triangle. Maybe even I'll go like this. What's the shortest? This side here is a little tiny side. What's the shortest that side could be? What happens if I fold that 7 side all the way down onto the 9 side? How far away will we be?
0.
No, it folds down to here. That only leaves us with 2. So this little side has to be bigger than 2. Can't be less than 2. Can't be equal to 2, or else we won't have a triangle. That's, I don't remember what that rule is called for triangles. We're going to do triangles today, so. Estimate 3 things at $19.95 each, plus 2 at $3.48. 3 things, $19.98 each, and we're going to add to that 2 things at $3.48. What are those? What is this number close to? Because we're estimating here.
20.
$20. Okay. Okay, so three $20 bills is how much money?
60.
$60. And then $3.48 is close to what?
350.
$3.50, and twice the $3.50?
7.
$7. Okay. So we're like approximately $67. Approximately $67. Last one. Okay. I'm going to copy it down. You guys think about it as... I'm just copying it down for our viewers. Oops. Square root it again, times 9 minus 2 square root times 9 plus 4 square root. Blah, 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 blah. 25 times 3. 75 plus 6, 81, square root 8. Wait, 9. Square root of 9 is 3. 3 times 9 is 27. 27 minus 2 is 25. Square root of 25 is 5. 5 times 9 is 49. 49 plus, wait. I lost track. What's the final answer?
I think it's 7.
Yeah. What happened? Hang on. 75 plus 81, 9, 3, 27, 25, 5. 5 times 9 is 45. Yeah. 45 plus 4 is 49, square root 7. All right, 7. Look at me and my background. Oh, my hands stay attached to me. All right. Will you please take a gander at lesson 35? There are a lot of things that I would have given you if I had this, but I don't. Those of you at home, you can take a screenshot of that. But we're gonna have some triangles here. I got some tangrams stuck to the board. I'm gonna talk my way through those. So please write this down somewhere, a piece of paper or something, because this is worth $12.53 of your time. I'm going to review some of the symbols that we use to talk about triangles, their sides and their angles. What we want to look for are triangles that are like each other, and then we want to look at all the different ways that they're like each other. That tea is hot. So, symbols. My friends, that is the symbol for equals. It could be numbers that are equal to each other, or expressions that are equal to each other, or today, sides or angles that are equal to each other. Or enough things are the same about two triangles that we could say that they are equal in size and shape and angles and all that kind of stuff. Yeah. Equal. And then similar, that little tilde thing, that little wiggly line deal, means similar. Similar things have, I'm going to go down and list some stuff here that we know to be true about similar triangles. First thing is that similar triangles have the same shape. Well, similar shapes, similar objects, we could say, would have the same shape. So triangles, obviously, they've got the same shape. And part of that is that if they're all right triangles or they're all obtuse triangles or something like that, they have the same shape. Second, they have the same angles. They have the same angles. So I would say, looking at my three triangles up here, that little guy here in the middle and big guy over here are the same shape, and they share the same angles. Okay, all three of them actually are similar. They have the same shape and the same angles. The third thing here, though, is pretty important, and this is that they have corresponding sides that are proportional. They have corresponding sides that are proportional in length. Now, we talked about proportionality yesterday when we did the sticky note math. And we said that this thing is to that thing as this other thing is to the other thing. Like girls and boys in the class, if the ratio is 2 to 3, there might be 10 boys and 15 girls. That's what proportionality means. So they don't have to be exactly the same size. You could have a small one and a big one. But if we looked at two of their sides at a time and matched it up with the other two sides that correspond, that are like that in the other triangle, one might just be a scaled up version of the other one. Like we did yesterday, where we took 1/2 and we could scale it up to 2/4 by multiplying the top and the bottom by 2 each. You could have a little triangle of sides of 1 and 2, and you could have a bigger triangle with sides of 2 and 4. But they're going to be similar shapes with the same angles and corresponding sides that are proportional in length. So this side here is EF. It goes along with this side here, TS, side 1. And then DE would be like side 2. Maybe I don't know what I was calling. And this, so EF is to TS as DE is to RS. This one's obviously the small version, and this is the big version. So maybe I'll make this, if that's a 1:2 ratio, this would be a 2:4 ratio. Not to scale, okay? I'm just using 10 grams, so, just go with it. But they're proportional, even though they're not the same exact size. They're the same shape, and they have the same angles, all the same angles. So two things can be similar and have a lot of things in common. But the ultimate is to be congruent, and that is to have the wiggle sign and an equal sign. So it takes all the qualities of two triangles that are equal and all the qualities of things that are similar and puts them all together. So things that are congruent or congruent, like what's his name would say, the Australian dude, they have the same shape, they have the same angles, and they have the same size. Last thing, though, is that the orientation might be different, but they'd still be congruent. So everything about them's the same, except one might be twisted in space compared to the other one. I've got two congruent triangles up here. If I took them and put them right on top of each other, I could get all their sides and angles and everything to line up. Exactly the same shape, same area, same everything. But their orientation's different. This one's pointed that way, this one's pointed this way. But everything else about them is the same. Okay, so this triangle and this triangle here. Can you see this? Yes. This triangle and this triangle. I'm going to remove those triangles. Same size, shape, angles, everything. If it's not obvious to the eye, mathematicians use little markings on their objects to show these things, that there's corresponding sides and corresponding angles. And here's how they do this. We say with the angles, that little thing means a 90-degree angle, and all 90-degree angles are the same. Then what we'll do is we'll sweep out a little arc up in the corner, and that tells us, if I do like one line, that tells me that those two angles are the same angle. And if I got a different angle down here, I would sweep out like two arcs. And if I do that on both triangles, I have a way of matching up the pieces. So angle S is equal to angle B. Angle R is equal to angle A. And angle T is equal to angle C. If I'm going to write down the name of the triangles and tell you that their parts are the same, I would do this. I would say triangle ABC is congruent to triangle, and then I have to do it in the same order. What lines up with A? R lines up with A. What's like B? S is like B. And then that leaves the third one. C and T go together. So the order still has to be the same, because what I'm saying here is, in this order, the angles and the sides match up. A, B, and C with R, S, and T. We can also mark their sides. And the sides, we're going to use a tick mark. So if we see that this is the longest side here, maybe we draw a little line through that one, and we draw a little line through this one too. But just one line. That tells us this side and this side are equal to each other, or that they correspond to each other. Then we got the tall side, which we might do 2 marks, and the base here, 3 marks. So we can match up everything in the first triangle with everything that corresponds with it in the second triangle. Okay? And correspond here doesn't mean that they're equal. It just means this one goes with that one. We're going to compare this one to that one. Now I've got a little triangle here that is a similar shape and has the same angles. So I would have angle 1, and then this angle, and that angle. That triangle DEF is similar to triangle ABC. Even though it's oriented differently, I can match up that angle E matches with angle B, angle D matches up with angle A, and angle F matches up with angle C. And if they are similar, that means that side D to F corresponds to A to C. That is the ratio of oh no, I shouldn't do that yet. Then this side, we've got 2 dash marks because it corresponds to side AB, and then this bottom one would have 3 marks because it corresponds with this one. So we'd say if this was I'll just call this one a 3, 4, 5 triangle for fun. No, I'll do it bigger. I'll make this one a 3, 4, 5. 3, 4, 5, not to scale. This one might be a 6, 8, 10 triangle. A 6, 8, 10 triangle. That is, if I take 2 sides here, and maybe I'll take the bottom side and the side over here. I'd say 8 is to 6. Side 8 and side 6. They match up with side 4 and side 3. Oops, no, 4 on top, 3 on the bottom. They have to be proportional in length, and hopefully that's the same fraction. 8 is to 6 as 4 is to 3. Okay? If I multiply 4 by 2, I get 8. If I multiply 3 by 2, I get 6. It's the same fraction. So this is how we would show that they're similar. They must be proportional in their lengths. And I only had to choose 2 of the 3 sides there. I can pick any 2 sides to compare in any order as long as the sides correspond from the first triangle to the second triangle. I'm going to keep working with this one. So I could pick the small triangle here and say the base 4 is to the hypotenuse 5. This side is to this side, as going over to this triangle, 8 is to 10. And if they correspond with each other, if they're similar, these ratios will be equal to each other. 4/5 is the same, has the same value as 8/10. Now I already know that these 2 triangles, that they're similar, because I can lay one right on top of the other one. This is hard to show. I can lay one right on top of the other one, and I can see, there we go. I can see that they've got the same angles. I can line up the angles, all of them, and then I can see that their shapes are the same as well. So the small one, multiply it by some number, it just scales up. Look, I can even scale it up this way. Oh, look how cool that is. Oh, for this camera. Watch, here we go. It's made smaller. Really small, really big. Same shape. I can scale them up and scale them down until I get that sweet spot where they're like the same shape. They might be different orientations, but everything else about them stays the same. That is that's kind of the rule here. There's two things working for us. And this comes from geometry. There's one called the side. Wow, hi there. Hi. Similarity. I don't know what it's called. Is it called a property, probably? That if the 3 sides are similar, the 2 triangles are similar. Whoa. And then there's another one That's the angle similarity theorem or rule. Similarity. That if the three angles are similar, then the triangles are similar. So both of these rules come into play in geometry, and they also are telling us something about these triangles, that we can mark them up and we can compare their sides, and we can see how they're all proportional. I'm watching you. So 1, 2. Okay, I got a 3, 4, 5 triangle. I can scale it up. Oh man, I didn't scale it up right. Let's scale it up with about if I went up to a 12, 15 something triangle. I could slide one on top of the other and everything would match up. The angles would match up. The sides are proportional. And so they'd do this and they'd say, so how long must this side be in order to fit the rule here? And I just have to pick two sides from this triangle and two sides from this triangle to compare with each other. And we'll be doing exactly the same thing that we were doing yesterday. I want to pick x is to one of these other two sides. And I'm going to pick 15. X is proportional to 15 in the same way that 3 over here is proportional to 5. Okay? X is to 15 is 3 is to 5. You can either do it by inspection, or we can cross multiply and divide. If we do the cross multiplying, we take that sticky note and move it over here. We get 3 times 15. And then if we take these two and multiply them together, we get 5 times x. 5 times x. So we want to solve for that x part, and we'll divide by 5. 3 times 15 divided by 5. We can simplify this a little bit. That's a 3, and that's a 1. 3 times 3 is 9. This side must be 9. I could have also picked different sides. Your job is just to pick two corresponding sides. That'll help you solve the problem. I could have gone over here and I could have said, I don't know what that side is, but I know that 12 is to x as 4 is to 3. 12 is to x as 4 is to 3. I'm taking the same things here and corresponding them. These ones go together. These ones go together. 4 is to 3 over here as 12 is to x over here. Can cross multiply and divide. So we see that 36, 3 times 12 equals 4 times x. And so my answer still is 9. X must be 9 so that the two sides can be equal to each other. I can do it one more way, and that would be kind of what I was pointing to here. I could say 4 is to 12, that relationship, as 3 is to x. That's also proportional. So yesterday when I was moving those sticky notes all over the place, we made all kinds of different proportions. We're doing the same thing here, just with triangles. 4 is to 12 as 3 is to x. This is the same ratio. This is a 1 to 4 ratio. We need the same kind of thing over here. We can cross multiply. Get 4 times x is equal to 12 times 3. So that's 36, or I can divide both sides now by 4. 12 fourths is 3. 3 times 3 is 9. The answer is still 9. That side is 9. Okay, so that's the job that you have to do in your math stuff. You have to make sure that you're matching up the sides that go together. You're making your own proportions, and then you're finding some missing details. I'm pretty sure that they're going to do that kind of thing a lot. Now, let me show you what was in what was in the reteaching down here at the bottom. It's hard. I got two cameras. I'm trying to show it to both cameras at the same time. There, that's a little bit better. They got three triangles. They're oriented differently, but we can match up which side goes with which side because they've got things marked. They've got... I'll do it here. Don't do silly stuff while I'm turned around. I'll represent these here. We got a triangle here. X, R, and B. That's right. That's side 1. This is 30 degrees. This one down here is 60 degrees. They've got 2 markings on this side. They got 3 markings on that side. This side is 20. This side is 10 in length. And then they got another one here that's oriented differently, and it's not the same size. It's G and J and H. That's what this one is. This is a 30-degree angle. This is the 60-degree angle. This is side 3. This is side 2. This is side 1. And they got a third one, which is even smaller. But they're telling me that all the sides and angles correspond with each other. This is angle M. This is angle N. Angle L. And this side is 5. And this side is mystery. We don't know. That's all the information that they give us. So we have to figure out what sides and angles and whatnot jive with each other in these triangles. So I'm going to call this triangle X, R, B. I'm going to say that is similar to triangle, and then I've got to put these in the right order. I got to find the angle in the second one that's like the angle here, X. And 30 matches with 30, so H has to go first. And then I went angle R, which is the 90-degree angle, so J comes next, and the third angle is G. And then I got to figure out what over here in this triangle is similar. I got to do the same thing. I got to match up the angles. So the 30-degree angle came first, so that's angle M. And then the 90-degree angle came second, so that would be angle N. And then we finish it off with the 60-degree angle L. So that's how they all jive with each other. And then we use the information that's given to figure out missing information about this one right here. Okay, I know that this is a 10 to 20 ratio of this side here to this side, of side 2 to side 3. That means that side 2 ends up being between the right angle and the 60-degree angle. And so this one right here, the 5 side, is side 2. Between the right angle and the 30-degree angle is side 1. So this one is side 1. And then the hypotenuse is side 3. Now they don't give me the length of this third side. So you do a little investigating. I've got the Pythagorean identity, or the Pythagorean theorem, in my back pocket. And it says that side 10 plus this one here, if I square them, 10 squared plus, let's just call this, I don't know. I'm going to make up a thing. That thing squared equals a hypotenuse squared. If I want to figure out this third side of blobbity-blob, the length of blobbity-blob there, I got to do this math problem. 20 squared is 400. 10 squared is 100. Plus something squared. So this must equal 300. And then I'd have to take the square root of it, and I could figure out that third side. So there's enough information here for us to start figuring out things. We would say then 10 is to 5 as 20 is to x. We could match these up. 10 is to, or maybe I'll do 10 is to 20. This side is to this side, as 5 is to x. 10 is to 20, as 5 is to x, because those are the corresponding sides. This is a ratio of 1 to 2. This has to be the same ratio. X is going to be 10. And I can solve for this missing part. Okay? I don't know anything about the side lengths here, so I can't make any statements about the lengths of the sides, but I know they come in these ratios or these proportions of 10 to 5 to something, of 20 to 10 to something, of 2 to 1. 2 to 1. That means this side 3 is twice as long as this side 2. I don't know what their lengths are, but I know that about them. All right, I'm going to shut that one off. I'm going to leave this one on. If you guys have any questions about 1 through 30, I'll leave it on and just make sure that I know that you're talking to me. The rest of you on the internet, watching this on YouTube later, good luck. Just know that you can always get a hold of me if you know where to find me. But I might be wearing my jammies. Just saying.